today an updated exam schedule. I really need a new word for that, but I don't know of one. It's not really an exam schedule, it's when each of you are coming to take your test. A few of you I have moved around because I did away with the 1:30 testing. So you three I know are somewhere different. You'll make sure you double check that. Make sure you're good with that. You don't have a time conflict, any of that good stuff. I do have it with me today. If you want to look at the end of class, we can do that too. Okay? All right. So what we're going to do is I'm going to quickly go over a few things you need to focus on in chapter 3. And then we'll talk chapter 4, and then I'll do a few math problems. Okay? All right, so these, looks like 5, but there's more than whatever. These things from chapter 4 would be multiple choice or fill in the blank. Make sure that you know how to apply all of them to a given situation. You have to know how to apply them to do the electron configuration correctly. So make sure you know what each one really means. And I talked about all of those at some point. Alright, then the only other thing we did in chapter 3 was electron configurations, orbital diagrams, and then we would assign quantum numbers to the last electron we placed in an orbital And remember I told you that I would ask you that as like a 3-part question. So for this element, write the electron configuration, orbital diagram of your valence electrons, and then assign the 4 quantum numbers. So normal elements, if you remember, I handed out this packet. Thank you. With this on it. This is what I'm talking about, normal elements. This is a good study tool. If you would like a new one, I have extra copies up here. You can grab it at the end of class. Then there were 4 exceptions we talked about in the D block. Be familiar with those. And then we did ions. Remember, for main group elements, the ion electron configuration is simple. It's usually just a noble gas. Okay? So usually where you need to spend the most time as far as ions go is reviewing your transition metal rules, because you have to take away the S electrons before D electrons, and y'all tend to forget that. Okay? So if you studied everything I have here for chapter 3 in detail, you got chapter 3 covered. Okay? On the exam 2 review, you can omit 10, 11, and 12. I usually test chapter 5 with 3 and 4, but we're not. So 10, 11, and 12 correspond to chapter 5. Other thing you might have seen on the exam 2 review is the very first question says something about list the 7 elements that exist in nature as diatomic molecules. I forgot to mention that, so I'm about to mention it. You already know one. You just might not know that you know it. When people are talking about oxygen in the hospital, what are they talking about? O2 is one of your 7 naturally occurring diatomics. So I'm going to list them for you. Now talk a little bit about them. Alright, so I drew them in a specific arrangement. 6 of the 7 make a 7 on the periodic table. It's nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Okay, and then hydrogen. That's your 7th one. So all 7 of these elements, anytime we're talking about nitrogen, we're talking about N2, not just nitrogen, because nitrogen isn't going to exist in a stable form as just N. It's N2. So when you name these guys, you're just going to name them as their normal singular element. It's not dinitrogen, dioxygen, none of that. It's simply oxygen, nitrogen. It's just what it is. Alright, so now we can talk a little bit about chapter 4. A good bulk of chapter 4, or half of chapter 4, is naming, okay? So my guess, I haven't made the test, I'll do it after this class and I'll send y'all an email with the format. But my guess is I'll do 10. I give you the formula, you're going to give me the name, then 10, I give you the name, you give me the formula. Okay? That's the first part of chapter 4. And the next part of chapter 4 is all math. So then you can expect one of each type of math problem. So I'm going to start with the hardest, then we'll work our way to the easiest. This marker doesn't work well. So this isn't the hardest, but it's kind of in the middle. We'll do a harder one. It's not harder per se, it's just more step after this. Before we do this, we need to talk about one of those words there. The empirical formula. Do any of you know what that means?
It's like the specific ratio of elements within a compound.
Okay, so it is, but specifically it's the smallest ratio of elements in a compound. The two only differ when you're talking about covalent compounds. Okay, so that's when you have several non-metals bonded together. Let me show you an example. Alright, so say I gave you this formula and I told you that it was the molecular formula, B2H6. And I asked you to find the empirical formula. Is there any way that I could simplify that down, that 2 and that 6? Yes, I could do a 1 and 3. Okay, so that's the difference. So in this example, we're looking for just the empirical formula. In a minute, we're going to take it a step further and we're going to find the molecular formula. So let's start with what we got first. All right, anybody know what I'm doing first? Yeah, okay, so most of the time, but not all the time, most of the time you're going to be given the percent composition of a compound. So each of the individual elements and their percentage within that compound. Those percents add up to be 100. Well, if you started with a 100-gram sample, these percents would be the same as grams. So if I had a 100-gram sample, 58.8 grams of that is just carbon. Okay, so you're going to take these percents and you're going to say, well, that's just grams. Okay, so I've got 58.8 grams of carbon, 9.87 grams of hydrogen, and then 31.33 grams of oxygen. That's the makeup of this compound. All right. When we are writing formulas, these numbers, these subscripts, those correspond to how many moles of each of those elements. So, first thing we need to do is we need to convert all these grams to moles. All you have to do, divide by each of their molar mass. I'm going to round it to 4.9. Kind of bad number. One point, what'd you say? Divided by 16. 6, close to 2, yeah. Alright, so these are the moles now, instead of percents or grams. Well, we can't just take these numbers and plug them in and make a formula. We've got to relate them somehow. So the next thing you do is you find the mole to mole ratio. Mole ratio. To do that, you take the smallest of your 3 numbers, and you divide all the other numbers by that smallest number. So for carbon, it'd be 4.9 divided by 1.96. For hydrogen, 9.8 divided by 1.96. Then oxygen, just 1.96 by 1.96. So you'll get 1 for that one. The rest, I get 2.5 for carbon, 5 for hydrogen, 1 for oxygen. Okay, so that's the mole ratio of these 3 compounds, these 3 elements in that compound. However, you've never seen a formula that had a decimal as a subscript, because you can't have that. So, you get to this step and you end up with a decimal that you can't round. You need to multiply all of these numbers by some number to get whole numbers. Okay, what can I multiply 2.5 by to get a whole number? 2. So I have to multiply all of my numbers by 2 then. And that's what I get. I get 5, 10, and 2. Now, I can use these numbers as my subscripts, because they're all whole numbers. So I plug them in as subscripts with my corresponding elements, and I have my empirical formula. So I don't think this is difficult, it's just remembering each of the steps. And I think I wrote out the steps in one of my videos. So we good there? Alright, let's take it a step further then. Okay, so if you get a problem like this and you don't have the empirical formula, don't be tricked. You must find the empirical formula first. Then we can deal with the molecular part, okay? So let's do that first. Let's go ahead, let's find our empirical formula, and then we'll do the next step right here. Okay, so we're gonna, again, take our percentages, say that they are grams, convert them to moles. Alright, so here's what I got for my mole numbers. Now we're going to divide all three of them by the smallest. So we're finding the mole ratio. Here's what I get as my mole ratio. What can I divide 0.33 by to get a whole number? 3. Correct. If you don't know, just go through the line. Do 2, 3, 4, 5 until you get a whole number. So multiply everybody by 3 so that I can make hydrogen whole. Okay, so now I've done the empirical part, and I get C3H4O3. That is my empirical formula. Anybody have a guess on how we're going to get to our molecular formula? You are correct. The only information I'm given about our molecular formula is its mass. So let's find the mass of this guy and then divide the two. Because they're some multiple of one another. solved for my molar mass of my empirical formula, I got 88.062. So now let's take this 264.19 and divide that by 88.062. 3. You get 3. That means these two are related by a multiple of 3. So to get your molecular formula, go through, multiply your subscripts by 3. So you get C9H12O9. Got your molecular formula. So as long as you can get to your empirical formula, you should have no problem taking it one step further and getting your molecular. Okay, so you'll practice that. Alright, just to run through real quick the other math that we've encountered in chapter 4. The very first math we did in chapter 4 was finding the molar mass of a formula. So we had to do that in this step right here. Okay, that was the first thing we did. Then second thing was we did percent composition. So, for example, what if I gave you this formula and I said, what is the percent of carbon in this formula? You say carbon's parked over the whole thing. So 9 times carbon's mass divided by the entire mass times 100. And y'all are familiar with that from lab as well. The one other thing that, where's the one I want to do? There's 2 ways we could do this. I can do it both ways. Yes, I have 13 minutes. One way I could do this is using that mass percent again. So let's do it that way first. Let's find the percent of sodium in Na3PO4. To do that, I'm going to say 3 times sodium's mass. I'm just going to type the next part in my calculator. I'm going to divide that by the mass of this entire thing. So again, 3 times sodium plus phosphorus plus 16 times 4. So the percent of sodium in this compound is 42.1%. So what would I do next? Just like you did in the fertilizer lab. You take your percent back to its decimal form, multiply it by the mass of your whole sample, and you get that out of that 8.5 gram sample, 3.58 grams is pure sodium. The other way, you're going to do the exact same thing, you're just going to do it all in one step. So the other way you could work it is you could start with what you're given, 8.5 grams Na3PO4. Okay. I need to get to just grams of sodium. Well, I can relate this compound and moles of sodium like this. For every 1 mole of this compound, there are 3 moles of sodium. I know that because of the subscript. Okay, so if I can convert grams of sodium phosphate to moles, I can use this and then convert moles of sodium to grams. So to get to moles, I need the molar mass, which I found right here. Okay, so grams of sodium phosphate would cancel. Then I would use that 1 mole of sodium phosphate has 3 moles of sodium. And 1 mole of sodium weighs 22.99 grams. That would hit equal. It's exactly what we did. It's 3 times 22.9 divided by 163.94 times the whole mass of whatever you started with. So it's up to you how you want to work it. But either way, you get the same answer. So in your textbook, in the back of the book, it's one problem says determine the moles of hydrogen. Let me write it out for you. determine the moles of hydrogen in 0.0885 moles of C4H10. This is just a simpler version of what I was doing here. So let's do it. Start with what you're given, 0.088 moles of C4H10. For every 1 mole of C4H10, put that on bottom. How many moles of hydrogen do I have? 10. I got that from the formula. Okay, so that cancels. I'll be left with moles of hydrogen. And that's it for your test. Okay. So again, make sure you check my email where I sent out who's taking their test when. I also posted it onto Moodle in the general section, or you can come ask me right now. You can pick up extra periodic table and practice for electron configuration. Don't forget, mastering's due tomorrow night, and I will see you guys Monday. Yes.